So greetings. The first problem requested in section 4.6 is number 4. And this is a short problem as far as the number of, or small problem as far as the number of words are concerned. So I just copied it down here so you don't have to go look it up. It says the sum of the two positive numbers, the sum of two positive numbers is 16. What is the smallest possible value of the sum of their squares? So, this is typical type of problem from here. We're trying to find the smallest possible value, which means we're trying to minimize something. So what we have to do is we have to start getting relationships down. We need two positive numbers and their sum to be 16. So let's get a fresh page here. So we can let x and y be two positive numbers, or the two positive numbers that we're going to use. And then we got to start writing the relationships based on what it said. Okay, so it says the sum of two positive numbers is 16, and we want to minimize the sum of the squares. So we add them together, we get 16, smallest possible value of the sum of their squares. So that means I have to add their squares together as a function and minimize that. Just to give it a name, let's call, whoops, I don't want to use that one. Let's just call f the sum of their squares. The sum of their squares would be x squared plus y squared. And this is what we're trying to minimize. Now, at this point, maybe I've given you enough help. And ideally, if at this point, you should try to move forward on your own, or at least at any point along the way. If you got to the point where I am, but after that you got stuck, pause at that moment and go see if you can finish, or maybe pause just after the next moment after I push you a little bit further forward so that you can see if you can finish it. In other words, you shouldn't watch the whole video without trying to do a little bit more work first. So what's the issue with this function? That's my next question. Hopefully you recall that every time we had an equation with more than two variables in it, we would try to reduce the equation down to just two variables. That's where this equation up here comes into play. This gives us a relationship between x and y that allows us to rewrite our function f in terms of just one of the two variables. So for instance, if I wanted to solve for y will be 16 minus x, and I can plug that in place here for the y and not have three variables in my equation. So I'm going to do that. F is going to be x squared plus 16 minus x quantity squared. So that is going to be our function down to two variables. The next step. What is the next step? Hopefully you're recalling that the next step is to find the domain, or define the domain of f here. In other words, find all values that we can plug in for x that make sense for this problem. Remember, the max or min depends on where we look for any given function, and so we got to make sure we are looking in the appropriate spot for this problem. So what do they tell us here? Well, they tell us we're adding positive numbers together, okay? So that means our x value has to be at least greater than 0. So we're looking from 0 to something else. How high can it be? Can it be as high as we want? 1,000, 1,000,000, 1 billion? Actually, no, because the condition that we have that they're both positive tells us that what we have in here, this 16 minus x, which is what represents y, that has to be positive also, which means x cannot be 16 or larger, otherwise we would get 0 or a negative number. So the largest x could be some number less than 16. So it's got to be on the open interval from 0 to 16. Those are the values that make sense for this. Hopefully that's enough. If it is, just pause the video and see if you can do the rest on your own. Otherwise, the next step would be to take the derivative. Actually, I'm sort of glossing over a step. One of the steps that we're supposed to consider is which method do we use, the closed interval method or the first derivative test for absolute extrema. I think, hopefully, obviously, we can't use the closed interval method here because we're not dealing with a continuous function on a closed interval. This is an open interval, and so we're going to use our first derivative test for absolute extrema. So let's go ahead and find f prime, and start working this. So we're going to get 2x plus 2 times the quantity, 16 minus x, times negative 1 via the chain rule. And so what do we do with this? Well, we got to find all critical numbers, which is where f prime is 0 or f prime is undefined. This is a polynomial that we're dealing with, so f prime is always defined or never undefined, as I like to say. And so now we just need to figure out when this is equal to 0. And for efficiency's sake, I'm not going to rewrite everything. I'm just going to slide in a set it equal to 0 and start doing some algebra here. So we get 2x plus 32. Actually, when I distribute this minus sign here, it should be a minus 32. So let me get rid of this and make it a minus sign. And then when I distribute the 2 and the negative, I'm going to get another plus 2x equals 0. So we're going to get 4x is equal to 32, which means x is equal to 8. That's our only critical number. And so what do we do with that? By the first derivative test for absolute extrema, we're going to divide our interval from 0 to 16 into two subintervals, 0 to 8, 8 to 16. It's the first derivative test, so we're plugging values from these intervals into the first derivative to figure out whether we have a positive result or a negative result on these subintervals. So over here I could choose like f prime to look at f prime of 1, maybe over here f prime of 10. It's your choice as long as the value is in the interval. Going back over here, if I plug in 1, I get, well, let's use this second line here. Let's use this line here. I don't need to worry about the equals 0 part. I'm just looking at the left side. And if I plug in 1, I'm going to get 4 minus 32, which is a negative number. So going back to this screen over here, I get something less than 0. Don't assume the other interval has a positive value. You'll want to check. If I plug in 10, I'm going to get 20 plus 20, which is 40, minus 32, which is a positive number. And so at this point, we know that because the first derivative is less than 0 from 0 to 8 and greater than 0 from 8 to 16, there has to be a minimum value of f at x equals 8 by the first derivative test for absolute extrema. You should write that down and explain that. I'm just not going to because it'll prolong the video to write all of that out. So now I know we have a minimum. I just expressed it verbally. Again, you should write it down. We know the minimum is going to be when x equals 8. So let's go back really quickly and figure out what happens or how we answer the question. I'm sorry. It says, what is the smallest possible value of the sum of their squares? Okay, so it doesn't actually want the two values. It wants the smallest possible value. So we need to go back and calculate f of 8. That's what this one's asking for. So f is x squared plus y squared. Now, if x is 8, then y is going to have to be 8 as well, because 8 plus 8 is 16. And so f at x equals 8 is going to be 64 plus 64, 8 squared plus 8 squared, which is going to be 128. So the answer is 128. That is the smallest possible value of the sum of their squares. Hopefully you got that, and if not, hopefully you found your mistakes and you're able to improve upon your technique here and be able to do better next time. Go study.